Today we're graphing logarithms, and the introduction to graphing these functions will be a reminder that a logarithm is the inverse of an exponential graph. The graph on your note sheet is an exponential graph. So here for name the parent function, it's exponential. Then I have instructions. Using the points on the graph provided, find and graph the inverse. So I drew in a grid with pencil because it was hard to see on my copy, and just I could easily see the 0, 5, 10 counting by fives blocks, but it was really hard to see the unit or the numbers in between. So I drew in a grid. If you want to do that for yourself, maybe that'll help you. Hopefully your copy is better than mine. But then I went and marked what seemed like points that were easy to read once I had a grid. So on the graph that's already on the paper, I have -1/2 and 0, 1, 1, 2, and 2, 4. I really only need 3 points to plot a curve, but I can easily read 4, so I took 4. The difference here, we learned in 7.1 how to analyze a table. When I look at the y values, each time I am multiplying times 2. That gives me the base for my exponential equation. So this graph is y equals 2 to the x. And I can know that it is a parent function because of this point 0, 1. If 0, 1 is on your graph, it's usually a parent function, not always, but 2 to the 0 power is 1. So if you put this into any graphing program, you should be able to duplicate this table for yourself. We learned when we graphed exponential equations that the domain is always all real numbers. So I can write that as -infinity to infinity in interval notation. And I would write it as the set of numbers x such that x is an element of all real numbers, and set notation. I went ahead and drew in my asymptote here. My asymptote is at y equals 0. So this curve curves up, and it's easy to see that curve. And on the bottom here, it's curving. It's still curving. Whenever you can graph this on Desmos or something, you can zoom in down here and see that it gets really close to this line. It'll never cross it. This is my asymptote, y equals 0. So because of this asymptote, and because I know it'll never touch that line, I would describe the range as parentheses 0 to infinity, or in set notation, I'd say the set of numbers y such that y is greater than 0, but not equal, because when y equals 0, that's your asymptote. My y-intercept I can pull from the table. My y-intercept is where x is 0. That's the y-axis. So that's at 0, 1. Using this table and the understanding that an inverse, which would be the logarithm, would be, if you trade the x and y values here, you can make a new table, draw your inverse graph, You can put your asymptote on there if you like to. I'd like for you to finish this, and I'm going to stop this, and I'll finish mine, and then we can compare, make sure that we agree on how this should look. So please pause this and do yours.